Hello everyone, in this video I'm going to share a high pressure steam PRV station. I like working with steam because I like the heritage to it, where we've been utilizing steam for buildings heat since the mid 1800s, and I think it's so cool that a lot of the buildings that we go to utilize it still today because of how efficient it is. Not necessarily efficient, but efficient cost-wise to utilize, and simplistic it is. So I'll break down this detail here on what all of these items mean and what it takes to properly get this high pressure steam down to a low pressure steam that we can use it to heat. So in this particular case, the high pressure steam was at 80 psi, and the purpose of the PRV station is it's a pressure reducing valve that gets it down to the pressure that a low pressure steam that you can utilize for heat. In this particular system, we were getting it knocked down to 12 psi. Okay, so we had 80 psi over here. The purpose of the PRVs is to get over here a 12 psi system to utilize for heating. So we first have isolation valves that are shown here. These are strainers, which pick up particulate in the line to protect the pressure reducing valves. We have manual pressure gauges here, so I'd assume these are somewhere around 0 to 100 psi gauges. They each have pigtails that in the trap of this pigtail condensate rests, so when the high pressure steam goes online, that little bit of condensate there protects the pressure gauge from damage. Okay, we also have reducers. So these are eccentric reducers, means they have a flat bottom so that condensate can't collect. Our typical concentric reducer would collect condensate, so that would not be ideal for this. These are unions that make maintenance of the PRV stations possible, because we could spin those and get the PRVs out. There is a bypass line here. I'm presuming if you had to work on one of your PRVs, you'd be able to close the valve to work on the PRV and open up the glow valve to maintain pressure as required. And these are isolated downstream as well with isolation valves. On our inlet side, if there's no requirement out of the PRVs based on the season that you're in, steam still being active on this line still will create condensate, which you will want to get rid of, which is why there is a trap station on the inlet side here with a thermodynamic trap, which sends it to the flash tank. So let's talk about this 1/3, 2/3, and how this 1/3, 2/3 system works. So how I look at the 1/3, 2/3 is for efficiency reasons, they don't want full capacity out of these two to maintain their pressure at any given time. So what they'll do is they'll put the 1/3, 2/3 in place based on the demand downstream. So what does that mean? So the 1/3 will be up to 30% capacity of what's required downstream. If it exceeds that, this 2/3 makes up the difference. So these are obviously sized accordingly, that there will never be demand that these two can't satisfy together. But if they can at all help it, they try to utilize the PRV1 for the most part to accommodate that. So what does that mean? So I think in the beginning of the job, it's pretty important to, if the drawings don't dictate what the pressure, if the drawings or specs don't dictate what the pressure requirements are downstream of the PRVs, it's not a bad thing to reach out to the engineer and find out what that set pressure point is. Okay. So this pressure indicator that you see here is basically just a pressure gauge. So basically we would want to know what that downstream pressure is that the system design is for. So in this particular one, it was 12 psi. Okay. So 12 psi is what we want to read here. So the pilot, each of these PRVs has a spring pilot here, okay, which has a sensing line that goes back to the PRV itself, and then this sensing line goes to your pressure indicator, okay? So if 12 psi is what we desire here, then our 1/3 valve, we're going to set that. There is an adjustment on the PRV, and we would want that set at 12 psi, okay? So it's always creating 12 psi to this system, all right? So what we want to do is we want to have a little bit of an offset on our PRV2. We wouldn't want that set at 12 psi because then the two would be operating at the same time. So what we'll do is we'll step back the PRV2 to probably, I don't know if it's like, it depends on how easy it is to adjust these, but I would say a pound would probably be what you want. So I would set my pilot on my PRV2 at 11 psi. Okay, so this PRV1 will satisfy this at 12 psi in the event that the demand is strong enough and this isn't able to keep up with it anymore based on the size of the line. Then it'll start dipping to, you know, that 11.5, 11 psi range, which is when PRV2 will kick on. And then that will make up the difference on the capacity to get it back up to the 12 psi that you're looking for. So these two are always kind of modulating to an extent, but basically we want PRV2 to fall off as soon as we can. We want PRV1 doing the work predominantly, if it can all help it. So with that said, so we got 12 psi here. Let me add those to the screen, the pressures of those. There we go. So our pressure indicator, this is nothing more than a pressure gauge, but we want to have the PRV1 set at 12, and we'll put our PRV2 set at 11. So up here we've got a pressure relief valve, which gets run to atmosphere. However you can do that, but obviously it's got to be done safely, so the roof would be a typical. But our pressure relief valve is set at 30 psi. So that protects any of the equipment downstream here. If you had an issue with one of these PRVs where they failed, you definitely don't want that 80 psi going to any of your equipment downstream here. It's not set up to support that. So that pressure relief valve goes off at 30 psi and will relieve all that pressure to atmosphere. So I'll touch base here on this pressure indicator. These pipe diameter dimensions are important because you don't want any turbulence in the line. So the closer that these get to offsets or transitions, whatever the case may be, you're not getting a consistent flow through there to get an accurate reading here. So you'll see this 10 pipe diameters shown before we get to the pressure gauge because they want to make sure that that line is running smoothly up to that point so that it's an accurate indication of what the system is doing. So that about wraps up the PRV station, the 1/3, 2/3 system. like I said, steam is it's pretty incredible what steam can do, and the heat, the BTU that it can produce. I know that on a lot of our construction projects where it's new build or renovation, where you've got decking and steel and just open to the elements that in the wintertime when we incorporate temporary heating means to these buildings. If you have a boiler room or a heating steam system available, it's just incredible that the amount of heat that they can displace. So anyhow, I hope you enjoyed watching this. If you have any questions related to steam, please let me know. I'd be happy to answer them for you. I appreciate you watching. Thank you.